Many of us are working on IoT designs these days. And one thing that IoT devices have all in common is these things need to communicate back to that internet of theirs. Now, sometimes that means a wire or a cable, of course. But I don't want to go running every morning with my wearable dragging a mile of cable behind me. And I don't think anybody wants to run a few hundred wires out to those agricultural sensors in the cornfield or monitoring the cows. I could go on, but the bottom line is this. We usually need wireless connections. And I don't think I'm alone here. I'm a capable engineer and all, but I don't really want to dive into detailed RF design. It's kind of complicated. And we have people for that. Hi, I'm Amelia Dalton, host of Chalk Talk. Today we're going to chat with one of those people. My guest is Rob Faludi from Digi, and we're going to talk about RF solutions for IoT and how LTE might be really awesome in your next design. And before we get started, don't forget to click that link. There you can find out more information about Digi's XBEE RF modules and modems. Hi, Rob. Thank you so much for joining me today.
Hi, Amelia. Thanks for having me.
All right, we are here to talk about the Internet of Things and LTE in particular. But first, let's talk about the different kinds of cellular technologies.
A lot of interesting things are happening with cellular right now. And in fact, there is a divergence occurring between two segments of the cellular market. For one thing, cellular providers are looking to support high bandwidth use cases. For example, tablets and smartphones, watching videos online, that kind of thing.
Right.
They require an awful lot of data download and sometimes upload, and typically batteries can be recharged on a daily basis, like with a smartphone.
Sure.
On the other hand, there's a second segment that the cellular providers are looking to support, and that's low bandwidth use cases. This is a type of requirement that a commercial or industrial machine might have, where it wants to report on its status periodically, but it has very little data to report.
Right.
It also has the restriction, though, of battery use. You can't go up to a diesel storage tank and plug it in and recharge its battery every day. You want that battery to last a long time.
Right.
So we have these two really different use cases. One requires a lot of bandwidth, but power is in ready supply. And the other really doesn't need much bandwidth, but you have to manage power properly. And they're both going to live on the same system. So that's what cellular carriers are looking to do. This has created a divergence between LTE Advanced and the low power, low bandwidth cellular protocols such as LTE Cat-M, also known as LTE-M, and NB-IoT. As the cellular carriers go to support both of these, there's really a fork in the road, two different paths. And we're mostly going to be focused on the low bandwidth paths for commercial and industrial support.
Okay.
Of course, cellular is not the whole show. There are many wireless and, in fact, wired technologies that can support commercial and industrial communications.
Right.
When you're connecting devices, you often want to think about where the device is, how far away it has to talk to, how many devices are in the same area, and as I mentioned before, battery power, that sort of thing.
Sure.
So you might be looking for a cellular solution because maybe you have one device that's sitting in one location and it needs to be connected to the internet.
Okay.
And one or two or maybe 10. However, if you have hundreds or thousands in one location, you might be looking to support a local type of network. And that's where mesh networking technologies such as ZigBee, Digi Mesh, and there are many others might come into play.
Okay, so how do these different standards really compare, Rob?
So the standards are divided up to serve different use cases. So, for example, you have the cellular technology that most of us use on our smartphones, 4G LTE. It's available globally. It is high bandwidth. You can move around. Obviously has mobility.
Yeah.
And your battery life is measured, well, on a good day in days, on a bad day in hours.
Yeah.
Then you also have other technologies that are more intended for connected devices than people.
Sure.
lower bandwidth, such as LTE Cat 1, which is lower bandwidth and lower battery use, LTE-M, which is very low bandwidth and really focused on saving power, and NB-IoT, which is the lowest bandwidth of all. The latter two are looking to support battery life for a matter of years, not days or hours.
Wow. Okay. So I've heard about LTE-M. How does that fit in here?
So LTE-M, which is also known as Cat-M, is a new technology. It's rolled out right now by a number of carriers, but we're still in the very early stages. By 2018, there will be broad support, and we believe also a large number of exciting solutions will become available as well. LTE-M is narrowband. It introduces new types of power savings. It operates off of a single antenna, which saves complexity and also cost.
Sure.
Both Verizon and AT&T are doing technology demonstrations as we speak.
Okay, so let's talk about NB-IoT. I'm not sure I've heard of that before.
So NB-IoT started off kind of as a competing standard to LTE-M. The 3G PPP group decided that they wouldn't make a choice between the two and would instead support both because they both address interesting use cases.
Okay.
NB-IoT is lower bandwidth. It also uses a single antenna, and it's really designed from the ground up for connecting sensors and low data need devices. NB-IoT is different from LTE-M in that it is more focused on devices and a little less focused on cellular. For example, it doesn't support things like SMS text messaging or mobility in the sense of handing off between towers. In the case of NB-IoT, typically you're looking at connecting a fixed asset.
Sure, okay. So let's talk about one of the most important engineering questions of all time. Rob, why would I build when I could buy in this case?
Well, it's an excellent question, and that's the reason I think we hear it so much.
Sure.
So buying versus building, always a question when you're creating devices, and usually there is a trade-off that you're making.
Yeah.
So if you build something from the ground up, in other words, and in this case specifically, we're talking about, buying a cellular chip and then doing a custom RF and electronic design, getting all the certifications,
right,
and all the time that takes.
Yeah.
And that can pay off. Doing a chip down design can pay off well, but typically it will take longer to get to.
Right.
You have lost some market opportunity window. You obviously have paid out more, but the return can be, in the end, lower cost, especially if you are making something with millions of devices.
Sure.
However, there's a lot of use cases where you're not making something for millions of devices. You might be making it for thousands of nodes, maybe even tens of thousands of nodes.
Right.
In that case, you might start all the way, for example, if you're only connecting a few devices, well, you might get a box solution like an external router. That way, development is very short and your ROI begins almost immediately.
Yeah.
However, the expenses are higher. In the case of an embedded solution, like an embedded modem, that's going to take some of your engineering costs out. It's going to get you to market more quickly.
Sure.
And it's going to cost less than a box product. For solutions that need to be done for thousands or tens of thousands of devices, an embedded solution, a modular solution, really can pay off.
Okay, so Rob, since we're at Digi, I'm guessing you guys have a solution in this space?
Well, you're not wrong. It's a good guess. We actually have a whole line of solutions. We make the Digi XBEE RF module. And it's actually a whole series of modules with different protocols and different features that address different types of use cases. We are the world's #1 selling RF module solution, and we've shipped over 10 million of them. So I like to think we know what we're doing.
Yeah, okay.
Digi XBEEs support all kinds of protocols. We talked about cellular, and I think I mentioned ZigBee. However, we also support 802.15.4, which is a point-to-point protocol. We have a proprietary mesh solution, which is a little different from ZigBee, kind of plays off of some deficiencies in ZigBee, fixes those, called DigiMesh. We also have Wi-Fi solutions and some sub-gigahertz point-to-point and mesh solutions in the 900 megahertz and 868 megahertz range. And Digi is also coming out with a Thread solution, which is a new mesh networking protocol. That won't be the end of the line. There's more stuff in the works, of course, as well. We want Digi XBEE to be a solution that a customer can come to us and get a future-proof embedded module. In other words, they put our embedded module in, it has a standard form factor, pinout, software interface, and in the future, if a new protocol comes along and that customer wants to use that protocol, the new one instead, they can pull out their existing XBEE radio, and there will be an XBEE radio with the same form factor, pinout, and software that they can install, and that future-proofs them.
That's awesome. All right, so Rob, what about the software situation here?
Well, software is, I think, an increasingly component of hardware, and XBEEs come with a lot of terrific software support. Two that are very important are the Digi XBEE configuration and test utility, also known as XCTU, which makes it really simple to configure and diagnose and test XBEEs. It includes also network analysis tools and a variety of development tools for working with the XBEE software API. We also publish code libraries for XBEE. That's a very important component to make them easier and faster to work with.
Sure.
And some of the modules are actually programmable as well. So we have code examples there too.
Nice. Okay. So, Rob, what if I'm knee-deep in my design and I've hit a roadblock? Can you guys help me out?
We'd love to help you out. In fact, that's a lot of what we do. We provide all kinds of additional resources, including great documentation, project samples and examples that you can build yourself.
Nice.
We have a series of other examples and guides, a great knowledge base, and we have a community, a discussion forum where XBEE users can come talk to each other and talk to us.
Cool. Okay. Now, as I have found, a lot of times security is an afterthought.
In fact, I'm always sad to have it come last. In many ways, I think security maybe should be the first thing you think about when you're making a design.
Right.
And therefore also maybe should be the first thing that we talk about. But traditionally, we come to it at the end, and here it is. Digi provides security actually in a structured framework we call TrustFence.
Okay.
And this includes a lot of different features that are all related together. For example, Digi devices feature secure boot, which means if a malicious intruder were to somehow come in and load their own software onto an XBEE, it would not be able to run. This is a very important piece of hardware protection. In addition, things that support this include encrypted storage, so security keys on our devices are always stored on a hardened chip that can't be read from once it's locked. We protect all of our programming interfaces, so those are locked as well. Basically, ensuring that even with physical access, our modular devices are protected against hacker attacks. Finally, TrustFence includes secure connections and authentication. So you know who you're talking to, and you know that no one is listening in between.
That is excellent. All right, so Rob, this is great in theory, but what about some use cases? What's really going on in the real world?
So many different things. I'll go through a few use cases that are very popular uses of Digi products, but of course there are many more, and one of the reasons I enjoy my job is that I get to find out all sorts of new things about various different industries as people come up with more and more terrific use cases for IoT.
Very cool.
But let's look at a few of the common ones. So, for example, one is oil and gas sensing. This is a big market and it solves a big problem. You're doing mining operations or drilling operations. In many cases, those are far remote to the organization doing them. So you have a company that's drilling, but they're not necessarily headquartered at the drilling location.
Yeah.
They want to monitor all the different machines, make sure they're all healthy. So in this case, you're looking at liquid level sensors. And these are installed in storage tanks. Often, if there are only a few storage tanks at a location, short range isn't a great fit for that. You would need a few radio nodes and a gateway.
Right.
And it's actually faster and cheaper and more reliable to connect to cellular directly. So in this case, each of the tanks would be reporting its status directly to the cloud.
Okay.
Sending alarms when there's a problem. Maybe there's less fluid than you want. Maybe the temperature is wrong. And that can initiate a truck roll. It can also initiate a truck roll in the right pattern to save the least amount of money by looking at all of the tanks, for example, that you're responsible for,
Sure.
and then making an optimized service map.
That makes sense.
Another example, solar energy. Very popular, growing market.
Absolutely.
So solar panels, again, are often not at the same location as the company running them. A lot of these solar panels are deployed as a service, for example, to residential consumers.
Sure.
These need to report data, how much sunlight they've seen, the health of the device itself, the current load that it's supporting. All of that information will go back to the managing company. And again, you probably don't have thousands of solar panels in one area, so you're talking a few in each location, and cellular connectivity is a great solution for that because it brings that device directly into the cloud where it can be monitored and controlled.
Right.
Another example, again, real example that we work with every day, security, in this case, a retail cash safe. So the cash safe typically doesn't have a lot to talk about. It just sits there and holds money.
Right.
However, it's opened, it's closed. It's important for security reasons to keep a record of that. And it also may be important to report alarms. Maybe the safe door has been left open. We want to hear about that right away. We don't want to leave it just to a convenience store in the field.
Right.
We want to make sure that someone is actually minding the money.
Yeah.
So again, you don't have tons of safes. You probably have maybe one or two per location. That's a great use case for directly embedding a cellular module. Let me show a couple others I think that are really interesting.
Okay.
So these are applications that could be cellular, but also certainly can be supported by local area networking, maybe with the cellular router as the gateway.
Okay.
So for one, there's an airfield lighting system. And here you want to make sure that you can turn the runway lights on and off. In fact, that is at small airports often done remotely, electronically from for example, a general aviation aircraft that's landing at a small airport may actually turn the runway lights on themselves from the plane, again
Right.
by radio.
Yeah.
All those runway lights then, of course, have to get that signal. And you may want to monitor them, especially at an airport that doesn't have a manned tower. You want to know how those runway lights are doing. Have some of them blown out? Did they actually turn on?
Right.
So all of that information can be reported back as well. It's very important because, as should be obvious, that's a life safety issue. It has to be reliable.
Right.
So a high-powered, for example, mesh networking module might be the right solution there. And we have an XBEE for that as well. Finally, here's a very common use case, smart cities. So specifically an intelligent street lighting system. You have a bunch of street lights, a very large number, all in the same general area, a municipality, a town, maybe a village, maybe a full-scale city. Each one will have a radio module in it. That radio module will report health and status data about the lights. They can also talk locally to each other. For example, you can have a street light that says, ooh, I'm burning out. It tells the two street lights next to it, and then they can increase their brightness to compensate.
Right. Okay.
So you can have both local decision making and remote control of the entire system. Mesh networking technologies are very good for that. And in fact, they're often paired with cellular either as a backup or a higher bandwidth method of communicating with these networks.
Okay, so we've talked a lot about cellular solutions. Can you tell me a little bit more about Digi's solutions in these space?
Sure. Let me show you something about the Digi XBEE Cellular functionality, basically the way that it works. So a typical solution is going to have Digi XBEE Cellular possibly talking to a local microcontroller inside a device. And that device could be a lot of different things. I typically think of them as generically as something like a vending machine, which has a status, it has an inventory, it requires health monitoring, and perhaps you even want to know what location it's in.
Right, I like that analogy, yeah.
Whatever you're monitoring, whether it be a vending machine or a tank or aircraft lighting, is going to be then transmitting data back and forth to a cell tower and the cellular network.
Yeah.
That in turn, over TCP/IP, the language of the internet, will talk to cloud servers, smartphones, etc.
Sure.
So this core functionality is displayed, of course, in a bunch of different ways for different use cases. It's going to be implemented differently for a aircraft tower light monitoring than it will be for example, a digital safe. But the basic structure is the same. You have local devices talking to a wide area network and typically being monitored from the cloud. Let me tell you also some specifics about Digi XBEE Cellular. It is fully FCC and carrier end device certified. That means you can take XBEE Cellular, install it into a finished product, and roll it out without requiring any additional certifications. This saves months of time and many, many thousands of dollars
for sure
of effort. Also, going through cellular certification process, certification is there for a reason. Not everyone passes. So you'll be working with a module that has already passed. It's got the authentic 20-pin XBEE form factor, software, and hardware interface. Everything works just like any other XBEE module that you would buy, and they are largely interchangeable. It runs off 3.3 volt power with a lot of low power options because, of course, optimizing battery use is extremely important.
Huge, yes.
And it's ready with TrustFriend security and firmware updates over the air. Again, very important because once you've installed your device, you may no longer have direct access to it, and being able to make changes securely over the air is fundamental to keeping a system running 24/7.
So, Rob, where's Digi XBEE Cellular headed? Where do we go from here?
Well, we're really just at the start of the journey for Digi XBEE Cellular. Currently, we have devices that operate on LTE Cat 1. That's a bit higher bandwidth, but still qualifies as a low bandwidth solution. We have a legacy 3G solution that's available globally. And Digi is, of course, going to support the lower power cellular solutions as well. We are in the final stages of building out an LTE-M Digi XBEE Cellular, as well as one for NB-IoT, and we are projecting those will have full market availability early in 2018. However, you have a few choices if you want to get started right now. Our 3G global solution is pin compatible with all XBEEs that are going to be released in the future, so that's one possibility. Our LTE Cat 1 is another possibility, again, pin compatible with all future XBEEs. Therefore, a design can be built with either of those devices, and then something like LTE-M or XBEE Cellular NB-IoT can be dropped in as those protocols are ready for commercial rollout. They'll be available, by the way, at select resellers such as Mouser.
Excellent. All right, so since EE Journal has an audience stretching around the world, what does the global footprint here look like?
Well, that's a very important question, and I'm glad you asked, because globally, this rollout is taking place, but of course, not at the same speed everywhere in the world.
Sure.
So in North America, right now, LTE Cat 1 currently available. Major carriers are planning to support both LTE-M and NB-IoT this year. Those rollouts are in progress, and we expect that wide availability will be 2018.
Okay.
Right at the time that Digi XBEE Cellular is available from Mouser.
Perfect.
In Europe, the story's a little different. The initial rollouts favored the NB-IoT protocol. However, there are other carriers that are looking at rolling out LTE-M. So initially, it looked like Europe was going to be NB-IoT only. Now it looks like it will be a diverse set of protocols to support different use cases.
Okay.
Australia, China, Asia Pacific have started down the same path. They've prioritized NB-IoT, but it's very early in this game. So I'm expecting regional rollouts may change over the course of 2018, probably 2019, and we'll have a good understanding at that point. This is where that flexibility for Digi XBEE Cellular really comes in. This is why you want to be future-proof.
Sure.
We haven't decided as a group exactly which radio protocols are going to be the winners for the Internet of Things. So manufacturers and customers need flexibility.
Absolutely. All right, Rob, this has been a lot to take in today. So can you give me your main points, please?
Sure. I think the most important things are there is a revolution on its way. Actually, there is a revolution underway.
Yes.
In low power, wide area networking, especially in low bandwidth cellular. It's happening right now. Availability of a lot of exciting new solutions will be in 2018. And Digi XBEE Cellular is the most secure, most future-proof, and of course, as I mentioned at the top, most popular modular solution.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Rob.
Thank you.
And before we go, you didn't forget to click that link, did you? There you can find out more information about Digi's XBEE RF modules and modems. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal or check out YouTube, keyword EE Journal.